Okay, so now you know when you are going to do a certain study or a research, you have to define the objectives, and then depending on that, you have to figure out the population that covers your objective, and then what is a sample. And in the previous examples, we already discussed, depending on the way you take the sample and the sample size, uh, the estimates you are going to get from the sample, the calculations you are going to get from your samples, these are going to be different. So if 5 people took who are going to do the same research, taking samples from different ways, different places, they will end up with 5 different samples, although they are doing the same study, but still they will end up with, when it summarizes their data, they will end up with different answers. That is common in sampling. Now, the problem is when you define your population contains the true values. If you want to find the average GPA of all third year students in AHS, you know the population. That will be all third year students in AHS. And if you find the average, considering all these students, that is the true average. But if you take only a sample representing third year students at AHS, depending on your sample, the way you collect it, the sample size, you will get an estimate or a guess for your actual value. Okay, now that value, the average GPA that you get from your sample, it's not going to be same as the true value. That is the true average if you consider the whole population, everybody. So the difference between the true value and the value you get from your sample, that is called the sampling error. Okay, so when your population is bigger and bigger, you cannot handle all of them. You cannot collect data from the whole population. So you have to go for the sample. And when you take the sample and do the calculations, your true values are for the population. They are unknown because you cannot collect everybody. Since they are unknown, you are going to guess it using the sample you collected. So the sample is uh, the best collection that you have close to your population. So any guesses or any calculations you do do that using your sample. Okay. So a sample is the representation of your population. So using your sample, you estimate or you guess, okay, what will be the true value? Just a guess or an estimate, the best guess you can have. But that's not going to be the exact same value as your true value. True value we don't know because we cannot do the calculation using the whole population because the whole population is very big, cannot access, it will take more time, more money. So what we have to do is only the sample. So the difference between the sample calculation, which is called the estimate or guess you do, that has a difference from the true value. Although we do not know the true value, usually that true value and the sample value that you get from the calculation, they are going to be different. So that difference is called the sampling error. Now, as statisticians, what we have to do is making that sampling error smaller and smaller as possible. Okay, we cannot make it zero. Okay, it's hard. We cannot make it zero, but what we try as statisticians is to make the sampling error as small as possible. So your sample will represent your population very, very well. So the guesses or estimates you make using your sample, that is very close to your true value. Okay, if it is very close, the error will be very, very small. Okay, so that in order to do that, you have to make sure the sample you take is a very best representation of your population. Okay, so that is why in statistics we have this sampling technique, that another different area that explains how to take a sample in order to make this sampling error very, very, very small. Relevant methods for based on the objectives of the study, what is the best method you can do, what is the best sample size you can go for. If you use the proper mechanism, you will end up with a very, very good sample. That is a very good representation of your population. So the sampling error will be very, very small. So which means your values are very close to the population. So whatever the predictions you are going to use making your sample, they are going to be very useful and very good. Okay, so that is the whole idea in statistics. Learning the sampling techniques is to make your sampling error small, because you do everything using the sample. If you end up with the wrong sample, everything you do will become useless. Okay, so that is why the sampling error, you should know about the sampling error and how to minimize it. Okay, so before we go into the sampling methods, now in this course we cannot go in detail about the sampling techniques, but I will touch some important topics. What are the sampling methods available, and how you use them and when to use them, and how to get a proper sample size. We'll look at it when it comes to chapter 6 and 7. Okay. Now, before we start the sampling techniques, you should learn some notation based on the population and the sample. Now, if you have any question, please stop me and ask me, okay? Right. So usually, let's say this is our population, okay? So here's our population, the bigger part. Usually the population size, we denote it with capital N, okay? The population size denote with capital N. So whatever the measurements you can do with the population, say for example, the mean or the average, okay? The notation is mu, the Greek letter mu. The standard deviation, we will talk about how to calculate them in the next chapter, but just know these are the measurements you can take. Standard deviation, which is sigma. Variance, which is the square of standard deviation, so sigma square. And you can have the median, which is the midpoint of the ordered data, usually denoted as mu tilde. And you can have proportions if there are groups, say male proportion, female proportion, or so forth. You can have capital P. Now these are called parameters. Okay, these are called parameters. So whatever the measurements you take with the population of size capital N, they are called parameters. Okay, usually the population is very big. As I mentioned, it's usually not accessible most often. Okay, so these parameter values are unknown. You do not know the actual values, because you can, if you want to calculate the mean, you have to collect, if it is a mean height or something, for the whole population, you have to measure their heights and then average it. But when you don't have everybody, access everybody and measure their heights, it's not going to work. Therefore, the parameter values, they are usually unknown. But what you can do is you can take a sample, right? So your sample is only a small part from your population. So your sample, usually we denote the sample size using simple n. So you see the notation capital N and simple n. Okay. So if you take a sample of size n, usually sample size n is very, very smaller compared to, considerably small compared to the population. Okay. So when you take the sample, this sample size is something that you can handle, like 100, 500, maybe 1000. Okay. But not like 100,000, so something like that. Okay. For the sample also, you can calculate the average. You can calculate the standard deviation, variance, median, and everything. But that is not the true value. That is only an estimate. Okay. So when it comes to the average that you calculate using the sample, you call it the sample mean. We denote it as X bar. Okay, X bar, sample mean. Now you can have the sample standard deviation. It's my short form for standard deviation, and that is S, capital S. Then the sample variance, we denote it as S square. The sample median, as X tilde. Okay, not only this, we'll come to the other measurements later, but all these measurements you can do for the sample. And then if it is the sample proportion, We use p hat. So whenever you see this hat, that means it is an estimate. So these are called estimates. You don't know the true value, but the best guess you can have. It's called the estimate. Okay. So the difference between the estimate and the parameter, so this is called the sampling error. Take the absolute value, that means dropping the plus or minus sign. So that is called the sampling error. Okay. So if your sample is very, very good, the sampling error will be very, very small. So that is our whole idea, to design your study so you get a very good sample, which is a very good representation of your population. Okay. So you know there are 3 layers in the world. Anybody? There are 3 layers in the world. I'll have the first one means good liars. Any guesses? Who's the second one? Good liars? Any guesses? Bad liars? Third one? Now you should guess the third one. Who can guess the third one? The third liar? No idea? Well, we're statisticians. Now do not laugh. Why do we say it? Because actually we don't want to fall here, but if you do the wrong sample, you will be a very, very big liar. Okay, the thing is, as I mentioned, the sample is the best representative of your population. For your study or for your research, if you end up with a wrong sample, if you couldn't follow all the proper techniques, proper sample size, and the way of collection, if you end up with a bad sample, which is not a good representation of your population, all the estimates you are going to calculate using a sample, they are going to be wrong estimates. The error will be very, very big. So you'll end up with wrong estimates. If you use this sample to do any predictions, inferences about the future, all these inferences or predictions will be wrong. Okay, can you understand that? If you end up with the wrong sample, everything that you are going to guess, all the predictions that you are going to make, it's going to be a huge lie. Okay, so the people will believe, okay, in 5 years of time, the temperature, whatever the atmospheric temperature will raise up to this value, the rainfall values will be on average this amount. So you say these things using a sample, and if you take a very bad sample, all these predictions you make about the climate changes, they are wrong. People will believe these studies if you publish them and everything. But if you use a bad sample, all these stories that you are going to talk about or the predictions, they are going to be wrong predictions, false predictions, and you are misleading people. So that is why you say you will become the third liar in the world if you do not take a proper sample in your study. Okay. So what we are trying to do is not to fall in this category. Okay. So make sure you get a good sample which represents your population very, very well. So reduce your sampling error, and all the estimates you are going to calculate, they are good estimates. And then the predictions, the models you build, they are very good models. So you are not misleading anybody, but you are giving very good prediction to the public. Okay. So make sure you do not fall into this third category. Okay. So our job is to make sure you do not fall into that category. Okay. All right. So if you want to get a good sample, you have to follow some methods, the ways of collecting your data. Okay. So here are some sampling techniques that we are going to look at in this course. Now, these are not the only sampling techniques that are available. There are several other techniques. Sometimes you combine these techniques and get a hybrid method. Okay, so all things will be depending on the objective of your study. The sampling techniques, you can actually split them into 2 categories mainly. They are the probabilistic sampling methods. Probabilistic and non-probabilistic. So if you look at the list, the first 4 sampling methods will come under probabilistic, and the next 3 come under non-probabilistic. Okay, so give me a minute. Right, so the probabilistic and non-probabilistic. Again, there are several other probabilistic methods and several other non-probabilistic methods. But we are going to talk about only these, okay? Okay, let's start with the random sampling first, or sometimes we call it the simple random sampling. This is the purest form of probabilistic sampling, which is very easy to get. And the idea is to make sure everybody in the population has the equal and known chance of being selected. So everybody in your population, they have the same chance of being selected. That is what we call random. Okay. So when you have a huge population, it is usually very difficult to identify each and every person. Okay, but you have to select some from here and there without any order, without any predefined pattern or anything. Simply select persons or people from here and there, so everybody has the same chance of being selected. Now, doing that is not actually easy. If you think about a small class, say for example, a class of 50 students, if you want to select 10 for a certain task, out of 50, 10 students for a certain task, what you can do is the old method, you write all the 50 names or their index numbers and put them inside a hat, shuffle it, and pick 10 the chits from the hat. Okay, so your hat contains all 50. You shuffle it and pick 10 out of that hat. So that is random. Okay, you don't go for any method, any order or anything, just pick 10. So, and if you open those chits, those 10 names, the names that are contained in those chits, they will be the 10 students that you are going to select. Okay. Another place that you can see random numbers, selecting numbers randomly is the place where you have the lottery, draws, right? If you look at, there are several lotteries that's going on every day. In the TV, you can see that they put ping pong balls into a certain machine and shuffle it, right? Mix all the balls together and then select maybe 5 or 4 ping pong balls from that machine. So that is the random selection, okay? Any other place that where you can see simple random sampling? Can you come up with another example where you see this way of selection, the simple random sampling method? You have, maybe you haven't used the name simple random sampling, but that's what it was. Can you come up with any other example? I'm sure you all do that. Mixing and shuffling and then picking. Make sure that all the outcomes have the same chance of being selected by shuffling well when you play a certain type of game. Any guess? Anybody who can guess? Yeah, we do simple random sampling when you play games. I'm sure all of you play these type of games. at least in hostels. Yeah, cards. Yeah, thanks. So when you play the playing cards, you make sure you shuffle your deck of playing cards a lot, right? You shuffle it, and then you distribute the cards among your players, right? So you make sure there are no patterns, and nobody will get the good hands, right? So everything is well mixed. Okay, so that is another way of doing the simple random sampling. Okay. Or if you want to do it methodically, you can use software. Okay, or you can generate using a random number table. Okay, there's something called the random number table. And using a random number table also, you can generate a set of random numbers. Okay, so I'll show you how to use it. Here's a sample random number table. Okay, I hope you all can see this. This contains set of numbers without any order, bunch of numbers. Okay, they are ordered in columns and then rows. Okay, this is only a part of it. Okay, it continues actually. So how do you use this random number table? It's very easy. Okay, so I'll take an example. Now suppose you have a group of 100 students. Okay, there's a group of 100 students. Now suppose this is your population. And you want to pick only 10 students from this 100. Only 10 students. Okay. Now, if you want to use this random number table, what you are going to do is you have to find the numbers for these 100 students and then pick them randomly. Now, this is how you are going to do it. Before we see how you select it, first let's look at this table. Okay. Now, each and every column you see 5-digit numbers. Okay. So you'll see 5-digit numbers, right? According to the population size, you can decide whether you go for all these 5 digits or whether you split it. You can do it row wise or column wise. Okay, you can do it row wise or column wise. Give me 1 second, please. Okay, sorry about that. Okay. Now, for example, if you want to pick random numbers of 3 digits, what you can do is first you pick the starting point. Okay, to make it easy, I'll choose my starting point as this one. Okay, I'm choosing this is my starting point. And I need 3 digits numbers, and I'm going to continue selecting numbers horizontally. Starting from the first row, I'm going to pick numbers horizontally from left to right. I need 3-digit numbers. So how do you split it is, first will be 893. Next 3 digits will be 922. Next 3 digits will be 321. Next will be 274, 483, and so on. So I'll get a series of 3-digit numbers. Okay, right. If you want, you can do it from top to bottom. You can start it from somewhere middle randomly. Or if you want to go diagonal, that is also okay. Okay, so you can pick your starting point from left to right, or even right to left, top to bottom, or bottom to top, diagonally. You can do that. Now, in this example, we have 100 students. Okay, that means you have numbers from 1 to 100. Or you can, it's easy if you choose these numbers from 0 to 99. So that contains all 100 students. 0 will be the first student, 99 will be then the 100th students. Okay. So that means we need 2 digits. Okay. To represent 99 values, we need only 2 digits. Okay. Only 2 digits will be enough. Okay. So now to find 2 digits, and you need only 10 numbers because we are going to choose only 10 out of this 100 students. So you have to generate 10 random numbers of 2 digits in the range of 00 to 99. Is that clear? If you want to represent 100 students, you name them from 0 to 99. Okay. And out of the range 0 to 99, you have to pick only 10 numbers of 2 digits. Okay. Now I'm going to decide the starting point. Okay. There's no method to decide where you are going to start. Okay, but it's up to you. So I'm going to start from this place, 29, and I'm going to do down from top to down. Okay. I need 2 digits. Okay. So my first one is 29. So that means I have to pick the 29th student. Okay. So this is my first one in the sample, second in the sample, third, fourth, fifth, sixth, seventh, eighth, 9, and 10. So this will be my sample. So the 29th student will be the first in my sample. So who's the next one? Okay, so you need only 2 digits. Okay, so here are my 2 digits. Let's go it like this. The next will be the second. So the second person in the index, that will be my second. Next will be 61 student. Next will be 27 student. Next will be 40th. Next will be 44th. Next will be 28, 66, first student, 52, 52nd student. So when it comes to here, my sample is now done. Okay, so you see, you don't see any pattern here, just the numbers that you pick from your random number. So out of these 100 students, this will be the sample that you're going to select, right? If another person start a different starting point, he'll end up with another different set of students according to their index. Is that clear to all of you? Right. Okay, I'll explain it again, right? Do you need the same example or a different? Okay, let's choose another starting point and continue it. Okay, still you have 100 students. You have to choose only 10 out of this 100. You name these 100 students starting from 0, 0 to 99. Okay, so 0th student is your first student in the population. Second is the first, 01 is the second student in your population, and so on. Okay, so you have all 100 students. Their index numbers will be 0, 1, 2, 3 up to 99. Okay, and out of these 100 students, you have to choose only 10. Okay, so you have to pick the 10 index numbers. Okay, so the students belong to those index numbers. They will be in your sample, right? Now let's start it from another place. Okay, so I'm going to start it from this column because because in our sample we have only 2 digits, 0 to 99, 2 digits. You don't need 3 digits to explain this 100 students, right? Only 2 digits will be enough. If you use 1 digit, it will be only from 0 to 9. Then 10, 11, 12, those index numbers will not be there. So you have to be careful. You have to go for 2 digits. Okay. You need 2 digits to get 10 students, right? Now let's start from here. I'm going to start from here. Okay, again, it's up to you. Okay, you can choose a place where you want to do it. So I'm going to starting from this place. So, okay, here's my second sample, right? The same population, my next sample. So I start with 75 and I'm going from left to right. Okay. So my first student in my sample will be the student having the 75th index number 75. Who's the next one? Fourth one. Okay, so I have to split these numbers into 2 digits. 2 digits. Okay, right. So who's the next in my sample? 42nd student who's having the index number 42nd. That will be the third in my sample. Then the 93rd one, 13, 8, 2, 24, 10, finally 16. So the 10 students having these index numbers, that is my sample. Is that clear now? I'll explain another one with another number of digits, okay? Okay, so that's one example. So let's go for another example, right? Let's go for another example. Here's the next example. I have, again, let's say set of patients in a clinic. In this clinic, there are 500 patients. So this is my population. Okay, 500 patients. You want to take a sample of 25. Okay, you have to take only 25 patients. So they have their patient ID. Let's say their patient ID. Let's go from 1. Okay, 1, 2, 3 up to 500. These are the patient IDs. And you want to select only 25. Now, how many digits you have to choose from your random number table? Up to how many digits? If you want to represent all these 500 patients. Okay, give me a second. You have a question. Can't we pick the 10 numbers randomly out of different places within the same sample given? Out of different places, you mean from the random number table, different places? We don't do that. If you use the random number table, you go either column wise, row wise, or diagonally in order. Okay. We don't pick numbers from here and there from the random number table. Okay. But if you don't use the random number table and just pick from the out of your own thinking, okay, I'm going to choose if you say, for example, just randomly numbers that comes up to your mind from that out of your head, if you can do that, that's also okay. But you know, it can be biased, so that is why we go for a methodical one like random number table or software. Okay. Another question that is a good one. Can we get the same number again? Yes. If you use the random number table, sometimes you will get repetitions, then you have to drop it. Okay, then you have to drop it. Say, for example, when you read these numbers, say 27 appears again, then you don't use it, you skip it and go to the next number. Okay. So there can be repetitions. If you get a repeated number, you have to drop it and go for the next one. Okay. So thanks for asking that question. That's what you do if you have a repetition. Okay. Right. Now, what was my question? You have 500 patients. How many digits that you have to choose? How many digits that you have to choose? You have to go for 3 digits. Yes. Okay. So let's go from 1 to 500. So 1 will be 001, right? 001, 002. Somewhere here you'll get 25. Somewhere in between you'll get 127. And so likewise. So you have all 3 digits in the range 0 to 500. Okay. So your range is from 0 to 500, right? Okay. Now, let's pick a starting point. Where shall we start? Okay, so let's start from 26 to 30 column, this column, okay? And I'm going to start from this column, the last 3 digits. If you want, you can start with the first 3 digits. Okay, so that's also okay. Okay, let's start with the first 3 digits, okay? So we are starting from the first 3 digits and going down, right? Going down. How many, what is the sample size? 25, right? Right. Now let's try to write down these 25 patients, okay? Here's my sample and 25. Sorry about the mess. 1, 2, 3, 4, 5, 6, and so on. Maybe we'll stop somewhere here, right? Okay. Another question. Okay, if you choose 0, it will be up to 499. If you choose 1, it will be from 1 to 500. Okay, Vasana? Right? So it's up to you. If you choose 1 to 500, your range will be 1 to 500. If you get 0, you have to drop it. If you choose 0, you should go only up to 499. Otherwise, you'll end up with 501 patients. Okay, so that's wrong, right? So it's up to you. If you use 1 to 500, use it, or 0 to 499. Okay, that's how you do it. I choose 1 to 500 because if you, after 500, again, you have some 3 digits numbers. But if you choose 100, 100 is the only 3 digit number and all the others are 2 digits. So you have to drop a lot of numbers from the table. So that is why whenever you have the number of digits changing, starting from the next value, it's always good to go for 0, right? Because say, for example, your population size is 1000. If you use 1 to 1000, you need 4 digits. But 1000 is the only 4 digits. All the others are 3 digits, right? So you choose 4 digits in your from your random number, but most of them you have to drop because there are no 4-digit values from 0 to 1000. Only 1000 is there. So you do 0 to 999. Okay, so that's why I chose 0 to 99 for the previous example. But this one, 1 to 500. Okay. I'll show you about dropping, right? I'll show you in this example what we call as dropping. Okay, right. So here's my 3-digit number set. Okay, so remember my range is from 0 to 1 to 500. Right? So 1 to 500. Right. The first one is 365, and it is in the range. So your first sample will be the patient having the patient ID 365. The next is 339. It's also in the range from 1 to 500. So you select 339. Next is 264. That is also okay. Next is 191. Fine. 474. Okay. Now 890. What about this one? Is it in the range from 1 to 500? No. Right? You don't have a patient record for 890. There are no patients more than 500. So this you drop. That is what we call dropping. Okay, this sample ID, you don't have any patient with 890 patient ID. So you drop it. This is again you drop it. There are no 700s. Okay, so you drop these two, you go to the next one. Next is 159 patient. This again you have to drop out of the range. This also you have to drop. This also you have to drop. Next is 29. Patient ID 29 will be in your sample. 793 you have to drop. 319, no repetitions. That's correct. 156 patient. Okay. 841 you have to drop. Out of the range. This is also out of the range. Then comes 475. Right? So you choose 475 patient ID. 840 again you have to drop out of the range. Okay, so likewise you keep on going until you end up with 25 random numbers. So these are the patient IDs that you select in your sample. Okay? Is that clear to all of you? Right? So if you do that, okay, suppose you while you are doing the 25, you finish this column. What do? You go again top, starting from the next 3 digits. 446, 127, 807 you drop, 911 you drop, 68 you drop, and likewise you continue. Okay? Is this clear to all of you? Any other questions? Okay. Right, so this is how you use the random number table to get a sample. Right? Suppose your population is 2000. How many digits do you have to use? You have to use 4 digits. But you have to use 4 digits. And when you do so, again, you'll end up with a lot of like only your range is from 1 to 2000. Okay, any 3000 digits, 4000, 6000, all these will drop off. Okay, so that is how you use the random number table. If you want, you can go from left to right, right to left, top to bottom, bottom to top. Okay, as long as you indicate where your starting point is, anybody can do the resampling. Okay. Any other question? Now, if I ask you to pick 10 random numbers of 2 digits and giving you a starting point, can you do that? Okay, so here's an example. Okay, let's do a very small one. I want to pick only 5 numbers, 5 random numbers of 2 digits in the range 1 to 5. Okay, let's make it a bigger range. Hold on. 5 numbers of 2 digits in the range, let's say 20 to 50. Okay, 5 numbers of 2 digits in the range 20 to 50, and my starting point is, let's say, my starting point is the 10th row, this one. 10th row starting from 98, 14 and so on. Okay, so this one. 2 digits from left to right, 10th row. Can you pick me 5 random numbers of 2 digits in the range 20 to 50? Okay, so start doing it and give me the answers. Okay, I have one answer. "49, 50, 27, 26, 28. What happened to your 14? You start from 98, start from 14. Oh, no, 14 is not there. You're right. So 14 out of range. 49, 50, 27, 26, and 28. Yeah, that's correct. Yeah, 14 is out of the range. Okay, so okay, I need the range 20 to 50, so 14 is out of the range. Okay, so you start with 49. Okay, yes, I got another answer, Sarah. Thanks, Sarah. 49, 50, 27, 26, 28. Can all of you get these values? Okay. Vishusha? Yes, thanks. Yours is okay. I think it's the last one. Should be 28, right? 26 and then 28. Okay. Any other students who want to share the answers? Okay, okay, so these are the values again. Thanks all who shared your answers with me. So you have 49. Okay, you start with here, right? 98 is out of range. You drop it. 14 is out of range because we have the range 20 to 50. 14 is also gone. Next comes 49. Okay, so the first one in the sample will be the 49. Then you have 63. That's gone out of range. 72 out of range. 50, it's in the range. So you get 50. Then comes 27. 71 out of range, gone. 55 gone, out of range. 71 out of range. 82 out of range. Then you get 26. Are we correct? 49, 50, 27. 27, 71, 55, 71, 82, 26, and 16 is there, right? And 16 is there, and then 66. So 16 is out of range, so it's gone. 66, 28. So this is our sample. Right. Yes, if the sample contains 20 and 50, okay, in this example, they are included. Okay, so you have to choose 20 and 50. If they says you can't excluding them, then you have to drop it. Okay, Sarah? Okay, so in my example, I assume that 20 and 50 are there in the sample. Okay, but according to you, the way your sample is defined and the population is defined, okay, you have to define the endpoints correctly. In this example, I gave you the chance to use 20 and 50, right? So then you have to use them in the sample, right? So that's why you have to look at the population size and define the starting point and the end point. Whether you include them or exclude them, okay, clearly defined. Then you will not have any problem. Okay. Any other questions? Okay. Right. Another method is to use a software. Even online, you can ask. There are online calculators that will generate random numbers. The software that we are going to use in our course is Minitab. Even in Minitab, you can generate random numbers. Okay. When we do a lab session, I'll show you how to do that. Okay. And how to generate random numbers using Minitab. Okay. So for today, I'm not going to show it. But when you do a lab class, I'll show you how to generate random numbers using Minitab. Okay. Right. So sorry about the mess in this page. Anyway, I hope you got the idea about using the random number table. Okay. Right. So that is the simple random sampling. That was our first one, right? Next, we go to the systematic sampling. Okay, that's the second method. Systematic sampling is usually used with a list, okay, where you want to select the nth name or nth person in the list. Okay, so these are usually used with registers. You know, in schools or even patient records, you have registers with the patient ID or index number. Even if you look at the voting list in each and every Grama Sevaka, they have the names in whatever that Grama Sevaka Vasama, all the voters, all the registered voters, they have a certain number, okay, the registered number, and in a ledger or in a certain book, you have these records listed from 1 to whatever the number of registered voters. So if you have lists like that, and if you want to select a sample from that list, systematic sampling is the best way. Okay, so you should already have this list or a register. Okay, so this is how we do it. You have to look at the population size first. Okay, so your list contains the whole population. Okay, and then you decide your sample size, and then you cover the whole population, the list of population, and pick your sample by dropping or leaving a certain set of records in between. Okay, you pick the nth record and leave the rest of them, and you go for next n plus 1th record. Now this is how we do it. Okay, I'll again take a small example of 100 students again. Okay, so you have 100 students starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, up to 100. Okay, and you have their names and whatever other information. Okay, and you want to pick, let's say, again, let's say 10 students. You want to pick 10 students, right? If you want to pick 10 students out of 100, you can choose something called the gap. Okay, the gap. Let's say K. So you divide 100 by 10, so that gap will be 10. Okay, the gap will be 10. So what does that mean? You pick the first one, then you leave a gap of 10, and then you pick the next one. That will be the 11th one. And you give another 10 gap, You pick the next one, that will be the 21st person. Then you pick another gap of 10, then next will be the 31st. So likewise, if you do that, you will end up with, when it comes to the 91st student, you have all 10 students. Is that clear? You pick the nth one, first one, then after your k is 10. So you give a gap of 10, then you pick the 11th one. Then another 10. Okay, so that will be the 21st. Is that clear? So your gap is 10. Okay, so and that will cover the whole population. Okay, so this gap you have to calculate it actually according to the population size and the sample size ratio. Okay. If you choose your gap to be simply say 5 or something, then at somewhere in between 50 or 60, your sample is collected, but all the other 50 students, they are not, they didn't get a chance. Okay. So having a gap of 5 is not correct if you are using a systematic sample. You have to make sure you consider the whole population list. Okay, so this gap you have to consider. Okay, so you have to calculate this gap by doing the sample size and the population size, this ratio. And you don't have to go for the first one actually. Okay, if you want, you can go for the, you can start with the 4th person. Okay, you can pick your starting point randomly even. Okay. So there's no rule that you have to start from the first one. Suppose you are going to start collecting the sample from the 4th person. So here's your first one. Then you give a gap of 4. What is the next person to select? 14th. Next person to select? 24th. Next, 34th. Next, 44th, and up to 94th. You'll end up with 10 students. Is that clear? Okay. So this is very easy. Okay, you get the registered list. You have the population, everybody. And then you decide your sample size and find the ratio. So you get this gap K. So according to that gap, you can choose the starting point again randomly. If you want to choose that random using a random number table, what is the first place that you pick? That is also okay, right? So somehow you pick the starting point randomly, and starting from that, giving the gap, you select the list, your sample list. Okay. You can use systematic sampling if you do not know the population size also. Okay. So that actually comes under kind of non-probabilistic, but you can use it under systematic sampling also. Say, for example, you want to do, you want to give a questionnaire or ask a certain opinion from people who's passing by in a street. Or think about customers who leave a certain supermarket. You have to pick certain number of customers per day and ask a certain question about maybe about a product, whether they are satisfied or not. You ask the question, record the answer, and ask them to leave. Okay, you do that. But you do not know how many customers will arrive in a certain day. Okay, you cannot know the number in the morning. Okay, suppose you are going to start your survey at 8 o'clock and wait until the shop closes, let's say at 9 p.m. Starting from 8 a.m. to 9 p.m., how many customers will come and go? You do not know the exact number. Okay. But what you can do is you can study the behavior of these customers maybe for a week and get an idea. Okay, on average, on a day like today, there will be about 1,500 customers entering the supermarket. That you can guess. Okay, and if you know that, okay, about or around 105,000, okay, maybe 103,000, maybe 107,000, but you can roughly have an idea about the number of customers arriving this supermarket on a certain day. So keeping that as a guess, okay, suppose 1,500 is your guess. Okay, you can't just guess it. You have to study, observe it for a week or so, and then, you know, decide, okay, on average per day, this is the number of customers arriving in this shop. And suppose you want to pick out of this 1,500, you want to pick a sample of 100. You have to pick a sample of 100. What is your K? What is the gap? That should be your K. How do you find it? 1500 divided by 100. So your gap will be 15, right? Your gap will be 15. Is that clear? So what does that mean? You sit in front of this supermarket, the exit, okay? If you want to start with the very first customer of the day, you use that customer, okay? So the first customer, you stop that person, give a brief introduction. Okay, I'm doing a survey. Okay, this is the question you have to answer, and ask the question, record it, and thank him and ask him to leave. Then you wait another, so that the question that you ask will be the first, the second, third, fourth, fifth. Likewise, you skip the next set of customers, and the 15th one you stop. Okay, next one will be the 15th one you stop, and then ask the question. Actually, that will be the 16th one, right? If you ask the question from the first customer, right? If you use the first customer, then after 15, the 16th customer who's leaving the shop, that is the person you are going to stop and ask the question. Okay, and then you wait other customers will leave after the 16th. Who will be the next customer? 31st customer. Okay, 31st customer will be the next to stop. Okay, who's the next one? 46th customer. Am I right? You start with the first customer. Okay, let me do it again. Okay, so you stop the first customer, right? So the next will be, yes, the 16th customer. Okay, so if you use the first customer here, 1 plus 10 is the 11th customer, right? 11 plus 10 is the 21st. So 16, yeah, I was right. So the next is the 31st customer. Then you leave the 15 customers, and then 46th will be the next customer. So likewise, up to 9 p.m. until the shop closes, with the gap of 15 customers leaving, you will pick your list of your sample. Okay, so you ask the question from these selected customers with the gap of 15 customers leaving. Is that correct? Is that clear to all of you? Any questions? So that is the systematic sampling. Now, in order to pick this 15, you have to make sure you know at least a rough idea about your population. Right? And you can do this even in, sometimes the surveys or the, observational surveys that people do who are passing by in a certain street. You stop certain passing by passengers and ask a certain question about opinion about the constitution or something. Are you satisfied or not? So you have to stop the passing by passengers or who are crossing the road. Okay, in that case also you have to observe for a few days what is on average the population of passengers who will passing this street from 8 a.m. to 8 p.m. Depending on that, depending on the sample size you want, you pick the K, and then you stop each and every passenger according to that gap, right? And then you ask the question. So that is the systematic sampling, right? So this is very useful when you have patient records in registers. If you want to select in a clinics, they have the registers of patients. Okay, so if you want to pick patients from a register, you can use that. Even in schools, universities, the registrar has the list of registered students in a record. You can easily use systematic sample to select students from these records. Okay, is that clear to all of you? The only tricky part is you have to pick the correct K. Okay, so the whole population list is covered. Okay, right. So that is the second one, systematic sampling. So you have the simple random sampling, systematic sampling. Then comes the third one, stratified random sampling. Okay, stratified random sampling. Stratification, now this is a little bit different. Okay, so this is actually a very good sampling method. It's called the superior to random sampling because sometimes in your population you see groups, several groups of different characteristics. Say, for example, males and females. If your study has the objective of comparing males and females, you have to make sure your sample also contains proper proportions of males and females representing your population. Sorry. Now, suppose there are certain formations, say, for example, a factory having where there are very hard working jobs are there. Usually in factories with hard working jobs, you don't see many females, right? Your population will be most of males, right? So if you take a sample from such a population, you have to make sure the proper proportion of males and females are there. Okay, proper proportions of males and females are there. Even think about the university, the population. Think about engineering faculty. Usually there is a high proportion of males and low proportions of females, right? And when you take a sample of engineering students from the faculty of engineering, you have to make sure your sample also represents a similar proportion of males and females. So that is called the stratification. So you can call those different groups, they are called homogeneous. That means within the group, the subjects are common, their characteristics are common, homogeneous. But in between groups, they are heterogeneous. That's very different between the two groups, like the males and females. Okay. So, so you call them strata. Okay. So here's your population. Okay, suppose you have the males and females in your population. Suppose that ratio is 70 to 30. Okay. When you take the sample, your sample, if this is say 1000, your population will have 700 males and 300 females. When you take a sample of say 100, you should have the same proportion in your sample also. Your males should be 70% of this, so 70, and females should be 30. See, you have the same representation of your population in the sample. Can you see that? So this is called stratification. Okay, so these males and females, you can call them strata. Strata, okay, stratum 1, stratum 2. So stratum is the singular word, strata is the plural word. So there are two strata. Stratum 1 is male, stratum 2 is female. You have the same formation in your sample also. So that is called the stratification. Okay. So when you take your sample using the stratified random sampling, what you do is, according to your objectives in your study, you look at the population and identify these homogeneous groups. And it can be 2 groups, 3 groups, 4 groups. It depends on your objective of the study. So you have these different stratum and you find the proportion, at least the rough idea about these proportions, and make sure in your sample also you have the same type of proportion, the stratification. Okay. Now, why do you think it is important to have stratification? Yeah, I'll take another example. Okay. Now my study is, suppose my study is about, you have to estimate the average number of hours student spend in the library. So let's say an undergraduate, okay? An undergraduate. Okay. So let's say University of Peradeniya. Okay. Now, what do you think about the behavior of this spending or studying inside the library? Is it same for all the courses or study programs, or is it going to different between study programs? Think about the faculties that we have in University of Peradeniya. How many faculties are there? How many faculties are there? Okay, so you are now counting, right? How many faculties are there? Arts, engineering. Okay, I have an answer. Okay, 9. Yeah, thanks. Yes, Lahiro, there are 9 faculties. So, okay, I'm not going to list them. Med, Agri, Vet, Dental, Science, Management. Okay, let's put AHS at the top, right? Okay, so these are the 9 faculties. Now, what do you think? If you think about students who are in these 9 faculties, do you think they all spend in the library, the behavior of spending in the library, is it same for everybody? Is it same for everybody? Okay, think about an art student who's doing history or sociology. They have to refer a lot of books, okay? Maybe the internet, but a lot of books they have to refer. So they will use the library a lot. Okay, I don't know about nowadays, but usually art students, they have to read a lot. They have to refer a lot. So they use library a lot. But think about a engineering student. They do a lot of field work. That's how they learn. Okay, they do surveying, they do the concrete things, the bridges and everything, or maybe laboratories, electronics, computer things. They are not going to spend a lot of time in the library. They do practical things. That's how they learn. So if you compare a student who's doing engineering and arts, there is a difference because of their study program. Okay, the number of hours they have to spend in the library, it's going to be very different. If you think about the medical students, they refer a lot of materials, so they use the library a lot. If you think about even within the faculties, if you think about arts faculty, fine arts students who's doing music, do you think that person will play the violin inside the library? No, right? They are not going to use the library. The way they study is they play it somewhere outside or inside a room, not in the library. So that's the way they learn. So fine arts students, dancing, music, arts, they may not use the library a lot compared to other arts subjects. Okay. So likewise, depending on the study program or the faculty, even depending on the year, first year, second year, third, final, the number of hours they spend in the library, it's going to be very, very different, right? So therefore, if your research is about average number of hours an undergraduate spend in the library, you have to make sure your sample contains students covering all these study programs, If your sample contains only art students, it is going to be very, very biased because art students spend a lot of hours in the library. If you use only engineering students in your sample, again, that's going to be very biased. It is very low. And if you say, based off your sample of engineering students, the average number of hours an undergraduate in University of Peradeniya spend in the library is 12 hours per week, is that correct? That's not correct. That's only for engineering students. That's not going to cover your whole population of University of Peradeniya. Okay, so that is wrong. So that is why you have to figure out the stratification. So if you want, you can go for these 9 strata. Okay, 9 strata. Each stratum will represent a faculty. If you want to go inside the faculty years, first year, second year, third year, you can do that, substrata. And then you make sure you look at the proportion of students at current in the population of University of Peradeniya students. What is the proportion of engineering students in a certain time? What is the proportion of medical students in a time? What is the proportion of AHS students, right? So according to that proportion, your sample should also contain that proportion of AHS students, that proportion of medical students, that proportion of engineering students, okay? Usually the arts faculty has the highest number. Okay, the arts faculty has the highest number with 17 departments. So there will be, your sample should also contain a lot of arts students. But the dental faculty per batch, there's only 80. Okay, so the dental faculty should contain that percentage in your sample also. Okay, is that clear? So you have to figure out the correct stratification and do it. Okay. Is that clear to all of you, the stratification? Right. So inside each strata, the subjects should have same characteristic. Okay, but between the strata, they should be different. So that is called homogeneous and heterogeneous. Within strata, it should be homogeneous. Within, inside. Homogeneous means very, very close in characteristic. Homogeneous. In between strata, they should be heterogeneous. That means very different. Okay, arts and engineering students different. That is heterogeneity. But inside art students, all START students, they are same. They are homogeneous. Okay. So that is how you figure out the strata. Now you should not go for very large number of strata. That will make the things complicated. Okay. Make sure when you select strata, they are homogeneous within as much as possible and heterogeneous in between as much as possible. Okay. So that is the stratification. And then you use the proportion, and again there are equations that you can use to make the proportional allocation, the sample size and everything. Again, we are not going to cover all these things here, but just know how this stratification happens. Okay, any question about stratification? No? Okay. Right, the fourth type of probabilistic sampling is called the cluster sampling. Okay, now you can imagine the meaning. When you say a cluster, cluster is a group, right? Cluster is a group. So these sampling units will come as a collection of elements, maybe according to the geography or maybe according to the features, okay? So the most common usage of cluster sampling is geographical clustering, okay? Here are some examples: city blocks, housing units, hospitals, even the hostels. So these are actually clusters, right? If you think about now, think about a certain, let's say a housing scheme, okay? If you think about a housing scheme or a village even, okay, so here you have the main road and you have some roads here and there going. There's another one, the lanes. And you have houses alongside them, right? And few houses here. Okay, so these are households, okay, houses. Then here again, set of houses, right? So what do you see? If a person wants to select or do a household survey about maybe in this housing scheme, whether they are satisfied about their waste management, okay? So they want to know about whether these residents are happy about the waste management done by this housing scheme. So you want to go from house to house and ask this question, right? Suppose this housing scheme is very big and there are about 1,000 households, 1,000 houses. So it is not possible for you to go into each and every 1,000 house and ask this question. Sometimes they are not available, okay? The time is not good, even it will take a lot of time for you to go there. So what you are going to do is you are going to select only, let's say, 25 houses, okay? Now there are several ways to do that. If you use cluster sampling, what you do is you look at the geographical formation of these 1,000 houses. So you see that there are clusters, okay? So let's identify these clusters. See, this is one cluster. This is another cluster. They may be different in size, but here's another cluster. Here's another cluster. Here's another cluster. Right? So you see several clusters, right? So what you can do is you identify these clusters, okay? If you want, you can randomly select only few clusters, okay? So you identify, suppose you identify 7 clusters. You look at the the map of this place. Nowadays it is very easy. If you get the satellite image from Google, you can easily see the clusters. Okay, you identify 7 clusters. Out of these 7 clusters, you want to do it very easily. So you only select the clusters close to the main road. Okay, so that is your criteria, close to the main road. So you are not going to go inside this lane. This is just for your convenience. Okay. So you select select only, let's say there are 4 clusters close to main road. So what you do is you choose this cluster, second cluster, third and the fourth cluster. So you pick the first cluster, you cover all the households in the first cluster and ask the question and record it. You go to the second cluster, select all the houses in this second cluster and get the results. Then you go to the third and fourth and so on. These clusters, they are not in your sample. Okay, so that is how you do the cluster sampling. Usually this is used to make it easy accessible. Most of the time easy to access. Even if you do a research in a certain village, have a very rural village, hard to go. So you choose a cluster of houses. Okay, so suppose that cluster contains 7 or 10 houses. So it is easy. All the houses are close together. So you can go to these 10 households and collect the data. Okay, so likewise. So you don't pick all the houses, all the clusters and pick 1 or 2 houses from each cluster and do it, because then if you do that, you have to go covering all the places. Okay, that is not easy. So you choose easily accessible households with clusters and collect data from all the houses in that cluster only. The other hard to reach clusters, you can drop them from the sample. Okay. Although this is not very superior method like the stratification, this is also good in certain situations. Okay. Is this clear to all of you? Can you come up with another example where you can use cluster sampling? If you think about the university students, the hostels, you can consider a hostel as a cluster or a wing as a cluster. If you think about Vijayawardhana, there are 4 wings. You select one wing as the cluster and do whatever your questionnaire to all the students in that wing. It's going to be huge, I know, but that's an example. Okay, or you select one floor of a hostel as a cluster and choose everybody in that floor to your sample. Okay, so that is also a cluster because it's easy to accessible. You go to that hostel or the first floor, you cover everything. You don't have to go to the other floors. Okay, the second floor is the cluster you select. Is that clear? Right? And sometimes people, when we do think about that study about the pH level of water in lakes, right? In Anuradhapura district, what you can do is, in such a situation, you can look at the map of the Anuradhapura district and it will contain all the lakes in blue color, right? To the geographical map, you can see the blue color, the lakes. So what you can do is you can choose how you can reach these lakes, whether there are main roads, whether the roads are accessible to you even with a motorcycle. Then you select clusters of lakes. Usually you'll see that small lakes, they are clustered together. So you choose these clusters and select water sample from all the lakes in that cluster. If there are lakes far away, hard to reach, those clusters we can omit. Okay, you do that by looking at the map. Okay, so that is also a way to do the cluster sampling. Okay, so the whole idea is to reduce your cost and easy to obtain. Easy to obtain, easy access, right? So you don't have to travel a lot. Okay, easily accessible places only. Okay. Any other questions about cluster sampling? Okay. You know, sometimes you can, now we learned 4 sampling techniques: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Sometimes you can combine them. You can use a hybrid method, right? For example, think about a study about students in a primary school. Okay, so your primary school, you have grade 1 to 5. If you think about a school, usually they have A, B, C, D, E, or so on. So you can think these classes as clusters, right? You can think these classes as clusters. So grade 1, there are, if you have 1A, 1, 2, 1B, 1C, 1D, likewise up to E. So there are 5 clusters for grade 1, 5 clusters for grade 2, likewise. Okay. Now you choose a cluster. Say you are going to choose your cluster as class B. So which means from grade 1, you choose 1B. From grade 2, you choose 2B. Grade 3, you choose only 3B. 4, 4B. And 5, 5B. So this is your cluster. And suppose in each class there are 40 students. You don't need all 40 students. You need only 5 from each class. What do? You take a simple random sample. Simple random sample of 5 students from each cluster. So it is a hybrid method of cluster sampling and simple random sampling. Is that clear? Right? You don't have to pick all 40. Okay. If you have to pick all 40, you can do that. But if you want to do a simple random sampling inside the cluster, that is also possible. Or suppose this is a mixed school. Okay, there are males and female students. If your objective is to compare males and females, their study methods or something, you have to make sure your sample contains that proportion. So in each cluster, you take, say, sample of 10, representing the proportion of males and females according to the proportion in that school. So that means you have cluster sampling and inside that stratified sampling. Okay, so that is a hybrid method. So you can combine these methods according to the objective of your study. Okay, is that clear to all of you? Any questions? No, I hope you are not sleeping. Okay, right. So that's about the probabilistic sampling. Now we move on to the non-probabilistic sampling methods. Okay. When it comes to non-probabilistic, you don't have any equations to calculate the sample sizes. In the simple random sampling, stratification, clustering, or systematic, you have a certain calculation. According to the probability concepts, you have certain calculations, certain equations that you use in order to calculate the sample size. But when it comes to probabilistic, non-probabilistic sampling techniques, there are no calculation related to probability. Okay. So these are actually not very good sampling techniques, but sometimes you cannot go for probabilistic sampling due to the behavior of the population. In that situation, we go for the convenience sampling. So most of the time in medical researchers, if we have to do it in a very small time period, we go for convenience sampling. Okay. It uses the this is very inexpensive. This it uses the actually the according to the availability of the population or accessibility of the population. Okay, you use a certain type of pilot study to get an idea about the population, but you cannot use an exact sample size or using a calculation. You can't find the sample size. Say, for example, you want to do a research about, let's say you are going to take x-rays of newborns. Do you think there are very many x-rays that comes from newborns? Okay. It's very rare that you take an x-ray from a newborn. If there's a very urgent situation, very critical situation, only you go for an x-ray for a newborn. So if you collect data for over a year, you will end up with only 20 x-rays. You can't go more than that because that's the only available number of x-rays. So you have to stick with that 20. So that is convenience sampling. Okay. Otherwise, you have to wait about 10 or 20 years to select about 100 x-rays. You can't do that. So that is convenience sampling. Okay. So in situations like that, you have to use all available sample sizes, all available subjects to your sample, then you go for the convenience sampling. You can argue it in your when you write why you choose this sample size, because that is the all available population for your study. There's no other way to increase it. That is the all available subjects. So you have to go with that number, that is convenience sampling. Okay. So there's nothing much you can do with that. Okay. So what is available, you take it. That's it. Okay. And the judgment sampling is also very related to the convenience sampling. This is based upon the judgment of the researcher. Okay. So this is also an extension of the convenience sampling. So the researcher, from his previous experimental knowledge or from previous research, from common sense, the researcher knows, okay, the population size is about this much, and the sample I can select within this given frame is only this much. So that is the own judgment of the researcher. Based on that, you select a sample. Okay, so that is called judgment and sampling. Again, there's no way to do any calculation. Okay, any numbers, you can't do it. It's completely based on the knowledge or judgment of the researcher. Okay, but you have to make sure, if you are the person who's judging this sample, you should be very confident. Okay, this is the best that I can do. Okay, so this researcher must be very confident that the sample which is chosen under this method, this is the exact representation of the population. So that should actually come with the practice and from previous knowledge from the previous research and so on. Okay, so again, it's completely based on the judgment of the researcher. Okay. Then comes the quota sampling. This is like the non-probabilistic version of stratification. You do not know the exact number or the proportion in the population, but what you have is just a rough idea. Okay, so according to that rough idea, in your sample also you have a certain proportion. Okay, so you do not know from for sure the proportion of male to female is 70 to 30. You do not know that. Okay, there's no information about it, but from the experience of the researcher, he or she knows it's not 50-50. Usually males are higher and females are low. Then just roughly this person says, okay, I'll go for 60-40 or 70-30. Okay, so that is also a kind of convenience or judgmental sampling. You apply your judgment of knowledge into stratification. Okay, so that is quota sampling, right? So you don't know the exact percentage, but according to your judgment, you come up with a certain proportion. Okay. Then comes the snowball sampling. This is actually something very interesting. This is used when the researcher cannot get access to everybody in the population, but he has access to the first level. Okay. So what we do here is, I'll explain it using an example. Think about, okay, my study is let's say a job satisfaction survey. The job satisfaction survey among bank managers in, let's say, Central Province of Sri Lanka. Okay, so you want to do a job satisfaction survey. You have prepared a questionnaire and you have to distribute among bank managers in Central Province, let's say both public and private banks. Okay, now you do not know all these bank managers, right? But you know few of your friends. So what do? Okay, suppose you know the Candy BOC, the C Bank House manager. Okay, you know that person, and you know Nuwara Hatton National Bank manager, you know, and you know Matale NSB manager, and then you know again say Katugastota, you know the Ceylon Bank manager. Now what else? Let's say about another one. Give me a name. Okay, Mavanella, you know the Sampath Bank manager. So what do? You carry these questionnaires with you and meet your friends, these 5 friends, and ask them, okay, you will meet these managers of the other banks in your city around or in your region. Can you distribute among them? Okay, you know the BOC manager, he knows the other BOC managers, even the other people banks managers and everybody, right? So they have the connection. So what they can do is whenever they meet or, even with emails, they can share this questionnaire. Okay, you are not contacting other managers, you are only contacting these 5. Okay. So say for example, the Nuvareli HNB manager, he has contacts with all the other managers in Nuvareli. He will distribute it among all the other managers in Nuvareli. And there's another manager from another bank in Nuvareli. He knows everybody in the next city. So he will distribute it among his friends. So likewise, all the managers, at least about 75% of the managers in Central Province can be covered. Do you actually meet them? No. You only contact the first level, the 5 that you know, and ask them to distribute it for you. So they are friends and they are friends and they are friends, and it will go like an hierarchy. So that is why it's called a snowball. This person will give to another 2, maybe 3. This will give to another 2. This will give another 2, 3. Okay. So you know how this snowball happens, starting from the top of the hill. You have this snow cluster and it's coming down, and while it's coming down, it will gather the other snow, and when it comes to the at the end of the hill, this snowball becomes larger and larger and larger, right? Start with a small snowball, but when it's coming rolling down, it gather all the other snow around that ball, and the ball becomes bigger and bigger and bigger at the end. So that is why it's called the snowball sampling. So you start with only 5 managers. These 5 will distribute the next level, the level after that, like that, and you will collect at the end. Say after a month, you meet your these 5 friends. They will have lot of questionnaires, field questionnaires from their friends. So you collect them. So that is called the snowball sampling. So again, there's no way of calculating the sample size. It will all depend on the connections they have. These 5, the first level, according to the connection they have. Maybe you will not be able to cover everybody, but most of them you will be able to cover. Okay. So that is how the snowball sampling works. Even with your friends, you can do that, right? If you want to collect a sample of 25 from science faculty, you can find one friend from science faculty and ask him to distribute this among 25 of your friends and bring it. He'll do that, right? And you want to select 10 from the engineering faculty, second years, you give the whole set of questionnaires to the second year engineering faculty, your friend, and he will distribute among his friends and bring you the answers, right? So that is snowball sampling. Okay, so is that clear? Right. Okay, so this is how you do the sampling methods. Okay, right. So that covers the main sampling techniques, probabilistic and non-probabilistic sampling techniques. I guess I was talking a lot. You have to grab a lot. So let's do a small group. Well, you can do it as a group work, but you can do it individually. There are 6 different scenarios. You have to pick up the suitable sampling technique from the techniques that you have learned. Okay, so there are 6 scenarios or 6 studies. Go read these studies and come up with the most suitable method. Again, there's no one answer according to the way you justify it. There can be several answers. Even you can go for combined hybrid methods. Okay, but use the most suitable one. Okay, you can start now. I'll give you 5 minutes, maybe 10 minutes of time. Think about them. Okay, and you can use 1, 2, 3, 4, 5, 6 and write in front of it the most suitable sampling method you think. If you want to talk with me, that's also fine. Okay. unmute your mic and you can talk with me. Shall we share the answers? Okay. Okay, we have a lot of different answers. Okay, systematic, random, systematic. Third one, stratified. Fourth one, cluster. 5 stratified, 6 cluster. Okay, that's Zara's answer. Anybody else? Okay, 31. Who's she? Stratified, random, judgmental, cluster, random, cluster. Anybody else want to share your answers? First one, okay, Sashini says the systematic, random, clusters, cluster and snowball. Stratified, cluster and snowball. Okay. First one, cluster and random. Second, stratified. Okay, Manisha says first one, cluster and snowball. Second, systematic. Third, random. Fourth, cluster. 5, random. 6, cluster. Okay, Dulika, thanks for the answer. Right. So, okay, we have different answers. That's fine because according to the way you explain it. Okay, so yeah, systematic, random, cluster, cluster, stratified, cluster. That's Vasana again. Right. So let's go over them one by one. So I'll give you the way I came up with the answers, but this is not the exact, I mean the only answer. Okay. So there can be differences according to the way you explain it, right? So the first one, identify whether the customer prefers brand A or B among general public of Sri Lanka. Now this is a very huge population, general public, very, very huge population. Okay. So you may have to go for a combination. Okay. If you want to cover the general public, at least you have to look at the geographical way, maybe the districts. And within each districts, if you want to ask the question whether they prefer brand A or brand B, the best place is to go for a supermarket, right? Where they buy. So from a supermarket, the exit survey, that is the systematic sampling. So this will be a combination of, according to the way I explain it, you have to use the clusters, the districts, and then inside them, maybe you select few districts, and inside these districts, you select few supermarkets. And then from the exit, using systematic sample, you ask the question. Okay, that's one way. Okay, so you have to explain why you choose it. Or because this is a very huge sample, you can simply go for the simple random sample. Okay, from covering the cities all around the country, from here and there, you pick general public, maybe from the streets, maybe from the supermarkets, just a random sample, just a simple random sample. Because it is a very huge population, your sample will also be considered very huge. Okay, not very large, but a large one. So you may go for simple random sampling straight away. Okay, so that is one way of explaining it. Either you go for cluster and systematic hybrid, or you go for a simple random sampling. Or again, you can go for the cluster method if you go for households. If you're going to choose households and go into the households and ask the question, then again you will go for households, the cluster sampling. Okay, households of clusters. From each of these clusters, you select a random sample of clusters and then you ask the question from each and every household. So that is also another option. So there are several ways. So I saw several answers the main thing is when you answer questions like this in examinations, give the answer and explain why you chose it. Just do not write simple random sampling and stop, because I do not know what you had in mind when you're going to select this data set for this survey. Okay, explain why you think simple random sampling is the best. If you think the cluster sampling is best, explain how you do it using cluster sampling, because I choose these type of clusters that will cover the whole population. From each cluster, I go for this sampling method, likewise explain it. Okay, so again, as I mentioned, there's no exact one answer. You can come up with your design, but make sure you justify it, why you chose it. Okay, right. So this is a very broad population. Okay, so you may come up with several answers according to your justification, right? But the second one is actually not that much hard. QC manager wants to check quality of products passing through a production belt. Okay, now think about how you select it. Now, the production belt, you see the products, they will go in the belt, right? So the best the easiest one is to use the systematic, right? The QC manager, usually he or she knows per day how many products will be generated from this machine or from this production belt. And then if you need a sample of N, you get the K value and systematically, okay, you pick the first product, check the quality, leave it. Then you leave K number of items because the production belt is going. So you can easily count and miss the K number of next set, and you pick the next one and then leave the rest. And you pick the next one according to your K. So for this one, the easiest is the systematic. Okay, because usually the QC manager has a knowledge about the population size, and according to the sample size, easily they can find K. And since the belt is running, you can very easily use the systematic sampling. Okay. Now this one, structural engineer wants to measure quality of bricks stored as a block. Now, can you imagine how the bricks are stored in blocks? Have you seen in construction places how people, store bricks? Cubes. Okay, so it will be like this. Nice cube like this. So all the bricks, okay, according to the in a nice formation, you see this brick cube, right? This is how you have it. Now, if you want to measure the quality of bricks stored in a block, can you find a brick inside this block? Can you put your hand inside these bricks and pick one from the middle? It's very hard unless you break this nice formation. But what you can get is the bricks on the sides or from the top. That is the easy access. What do you call it? Convenient sampling. Okay, so this is very nice example of convenient sampling, because you can't go inside this brick block and pick the blocks from the middle. What you can touch is only the edges, the sides and the top. Okay, although you want to find the insides one, if you don't break this whole formation, you can't get it. So if they are in a nice block like this, you have to go with the convenient sampling and only pick the blocks that are available to you. Okay, so that is convenient sampling. Another one is if you think about the racks in a library or even in the hospitals, the patient records, you have very high racks and the files are stored. So sometimes if you don't have a ladder, you can't access the files in the very top rack. Okay, in that case, you only pick the files from the very middle of the rack where you have the accessibility, right? So that you can do, right? So that is also convenient sampling. Okay. If you go to the fourth one, identify opinion from residents regarding introducing a new nightclub pub in a suburban area. I think most of you found it as cluster because it's household survey. Cluster of houses will be easy, but look at the survey. It's about the opinion from residents regarding introducing a new nightclub pub. Now, if you think about the residents, according to their there can be several groups that will give their opinion in a different way, positive, negative. If you think about a very young generation, young crowd, they may have a positive opinion. But if you think about the older people or even the females, they may not be very satisfied about having a pub in the area or a nightclub, right? So there are differentiations in the opinion depending on the age and the gender. So you can combine this with the stratification, okay? Because the opinion can change dramatically in between this cluster, this strata, male, females, younger generation, older generation, it depends, right? And even the cultural behaviors, right? So cluster, I think most of you have identified this as cluster because when it comes to residence, clustering is the easiest, easy access, households. But within the clusters, you may have to go for stratification because of this, the sensitivity of this topic. Okay. Calculating GP of PGI students, I think I saw the stratification in most of you, yes. Because when it comes to GPA, it depends on a lot of different groups. Maybe the study program, maybe the MSc, MPhil, PhD, that's categorization, that is the year of study, first, second year research, coursework only. So stratification is the best, right? You can hit the degree program and also the level of the study. So I think I saw stratification in many of your answers. So good. Then comes the household survey on their knowledge about the new constitution. Again, it's the household, so easiest is the cluster. Right? You can go for the cluster. And if you want to go for a hybrid method, if you have any justification on that, okay, you can mention it, right? So again, these are not only one. Okay, as I mentioned, you don't have only one answer, right? If you think rather than convenient, there's another way, explain it, justify this is why I choose this type of sampling. Okay, and well, I don't have any other option but to give you marks if you have a very good justification. Okay, so when it comes to exams, if you have to write the suitable sampling method, do not just write the name of the method, justify your answer why you choose this method. In that way, you can get full marks. Okay. Any other question? I guess this is the end of the today's lesson, right? So we have talked about all the sampling techniques, relevant sampling techniques, why we need the sampling techniques, why we have to reduce the sampling error and everything. And we talked in detail about how to take a sample using random numbers and everything. So I think that covers our second section. Any other question? So what I'm going to do next time is to show you how to prepare a questionnaire. Okay, so that is one way of collecting information in surveys. There are several methods of collecting information. So we'll look at those data collection methods, and in detail we'll look at how to prepare a questionnaire because that's going to be very useful in your final year research work. Okay, so that will be our the topic for our next day. Okay, any other question? Can you stop for today then? Okay, can you upload the lecture records to Moodle? I can actually, I was discussing this with your department. I can upload this document with what I have written on it and all the explanation to your Moodle. Yes, I'll do that. I'll upload this document to your Moodle. So this document will contain 2 lectures, the first one and the previous week and this week. And there will be only one document for both, so I'll upload it, okay? Any other requests? Okay, then shall we stop for today and hoping to see you next week.